Hey guys, today, this problem, I'm going to do homework problems. I haven't looked at them yet, so if I take a little second to comprehend. Okay, the first one says the disassociation of perchloric acid. I'm not going to write out the whole problem. I'm just going to write out the acid they're asking me to disassociate. I know what perchlorate is, and it has no charge. Okay, so the disassociation of perchloric acid. We're going to start with perchloric acid, which is HClO4, and disassociating it, we're adding water. Well, it's with water, I guess. H2O is a liquid, and we know that we must have our acid, our H3O plus, aqueous, aqueous, plus our, I like to look at this right now, is the conjugate base. Our conjugate base, ClO4, 1 minus. And the reason I put a forward reaction, I didn't put sort of the backwards reaction or the inverse reaction, is because HClO4 is a strong acid. And relatively speaking, this dissociates almost completely in water. So what I also learned is that with acids, when we're writing the reaction, sometimes they don't write water as a reactant. Also because the equilibrium constant, K, let's say, of perchlorate, is not going to include water because water is a liquid, and we're not including liquid in our equilibrium constant. So I guess I could also write it like this, and it wouldn't be incorrect, and it would also save me time if I'm on an AP exam or something, because obviously if it's aqueous, it's sort of common sense, but whatever. Okay, B says disassociation of propanoic acid in water. Well, propanoic acid is CH3, CH2, CO2H. Just from looking at this, I can see why people would get scared, but I can also sort of, you know what I mean? You can make that connection. But whatever. Okay, I'm going to write it without water because I don't need to. But one thing I want to note here now is that looking at this, there's definitely going to be a reverse reaction, right? I can just look at this and see this is 100% a weak acid because I see the carboxyl group, right? So that's sort of the connections we're supposed to be making. Whatever. So I have CH3, CH2, CO2, and yes, you can be writing your plus water. I'm not going to, and I'm going to put the forward and the backward reaction, and it's going to give me my acidic proton, and that's going to be, I know you can just sort of look at it and be like, okay, bye, but that's going to give me CH3, CH2, CO2 minus. So we can see our conjugate base here, right? Connection to make here right now is I know this is a weak acid, so I know my conjugate base is going to be strong, and I know that my conjugate base is going to be stronger than water. So I just want to note that. Okay, C says the disassociation of the ammonium ion in water. The ammonium ion is NH4 plus, and ammonium ion is a weak acid, so I know that it can have a forward and a backward reaction. I'm gonna put weak here. I sort of memorized this. You'll eventually it'll click, but I'm also once again not gonna write the water. So NH4 plus, aqueous, forward and backwards. We have our proton, our acidic proton, and we know that we're gonna have an NH3. I don't know if this method of rationalizing is correct, but for these problems, I see that there's a plus, and I'm okay, I can remove one, right? I can remove one. That's sort of how my brain clicks everything together. So I don't know, it's maybe just a little hurt in my head. Okay, that's it.